Hello everyone, my name is Abdullah Hanan and this is my video for the Microwave Electronics course project for Bilkent University. The project was to design a two-stage low noise amplifier for a frequency range starting from 5.985 GHz to 6.615 GHz. The project had some specifications which were supposed to be met, like the input reflection coefficient should be at least 7 dB, the output reflection coefficient should be at least 15 dB. The design should be unconditionally stable, and the gain should be as high as possible. The IP3 should be as high as possible, while the noise is as low as possible. So here is my design. As you can see, we're using Cree's this transistor from Cree's libraries. The first transistor has a periphery of 310 by 2, which means it has a gate width of 310 and two fingers, while the other one has a gate periphery of 750 by 2. These were chosen so that it could be optimized for the first stage for a low noise and for the second stage a high gain. In the first stage, we also have source gain generation so that a lower noise could be achieved. Other than that, these transistors are biased using a 28 volts drain voltage and 100 milliamp per millimeter drain current. For that, minus 2.786 gate voltage was used. After stabilizing both of these transistors, the input matching of the design is shown to the left, while the output is shown to the right. And in the middle, we have our interstage matching network. After doing the design with the ideal components, I ran some simulations to make sure that it was working fine. As you can see over here, the stability factor is greater than 1 for the whole frequency range, so it is unconditionally stable. Um, the noise figure in the frequency band is about 2.8 dB. This is the S11 and the S22 plots. As you can see that the S11 and the S22 inside our frequency range is below -7 and -30 respectively, sorry, -15 respectively. This is the gain of the two-stage amplifier. The gain is about 25 dB, and the ripples are limited to plus minus 0.5 dB. The output IP3 is 39.7. After doing the design with the ideal components, the components were then replaced by real components from the Cree's library. This is the whole schematic after all of the components were replaced. This is the transistor of the first stage, and to the left we have our input matching network, and on top this is the biasing network. Mm, This is the second stage, and in between we have our interstage matching network. This is the bias network of the second stage, and this is the output matching of the second stage. A layout was then generated corresponding to this schematic, and finally it looked like this. This is the transistor of the first stage, and this is the transistor of the second stage. We placed the DC probes for the gate voltage and the drain voltage for both of the transistors. We also have the RF ports at the input and at the output. The dimensions of this MMIC is 5.3 millimeters length and a height of 1.3 millimeters. Finally, simulations were done on the schematic with the non-ideal components. Again, the stability factor is greater than 1 for the whole frequency range, which means the design is unconditionally stable. The S11 and S22 requirements are also met, as the S11 is less than -7 dB for the frequency range, while the S22 is less than -15 dB for the whole frequency range. The noise figure increased a little to 3.0 to 3.4 dB in our frequency range, and the IP3 is now 38.5 dB.